Did you know the first known computer, the abacus, was invented by the Chinese around 4,000 years ago? Yes, the journey of computers began centuries ago. These machines have since evolved from simple counting devices to powerful tools that drive our modern world. Computers are the electronic brains behind countless tasks in various fields. From education and healthcare to business and entertainment, they store, retrieve, and process information with incredible speed and accuracy, making our lives easier and more efficient. Whether it's for crunching numbers, connecting people across the globe, controlling transportation routes, or creating captivating multimedia content, computers are indispensable. Over the next few minutes, we'll explore the fascinating journey of computers from the humble abacus to the supercomputers of today. So, buckle up, because it's going to be an exciting ride. Every computer, regardless of its complexity, is made up of a few basic components. Let's delve into what these components are and the roles they play in making a computer function. At the heart of every computer lies the motherboard. Think of it as the central hub, holding together all the other pieces of the computer. It's the main circuit board that houses the CPU, memory, connectors for storage drives, expansion cards, and ports. Next, we have the CPU, or central processing unit, often referred to as the brain of the computer. It's responsible for carrying out all the commands and operations that a computer performs. It's like the conductor of an orchestra, directing all the other components to work together in harmony. Then we have RAM, or random access memory, which is the computer's short-term memory. It temporarily stores data that the computer is actively using. Imagine it like a workbench, holding all the tools and materials you need for a project. The bigger the workbench, the more projects you can work on simultaneously. In contrast to RAM, the hard drive is the long-term storage for software and files. It's like a filing cabinet, keeping everything organized and ready for when you need it. Whether you're saving a document, installing a new app, or downloading a movie, it all goes onto the hard drive. Finally, we have the power supply unit. As the name suggests, it's responsible for supplying power to the computer. It takes electricity from your wall outlet and converts it into a form that your computer's components can use. To expand the computer's capabilities, there are expansion slots on the motherboard. These allow for the addition of extra cards, such as video, sound, network, and Bluetooth cards. Each of these components plays a crucial role in making a computer work. They all work together like a well-oiled machine to ensure that your computer runs smoothly and efficiently. From the abacus to the supercomputers, the evolution of computers is a fascinating story of human innovation. Over 4,000 years ago, the Chinese invented the abacus, the first known computing device. But it was not until the 19th century that the journey towards modern computing really began. Charles Babbage, often referred to as the father of the computer, developed the difference engine and the analytical engine. These machines, which used punch cards for input, were the precursors to the computers we know today. Fast forward to the 20th century, the first electronic computer, the Atanasoff-Berry computer, was introduced in the United States in 1930. But the true game changer was the Electronic Numerical Integrator and Calculator, or ENIAC, designed by John Mauchly and J. Presper Eckert in 1945. This was the first general-purpose electronic computer, a significant leap from its mechanical predecessors. Then came the invention of the transistor in 1947 by William Shockley, John Bardeen, and Walter Brattain. This revolutionized computer technology, leading to the development of smaller, more efficient machines. The introduction of integrated circuits, or chips, in 1958 further increased the speed of computers and reduced the need for soldering. The 1960s saw the rise of mainframe computers, and in the 1970s, personal computers like the Apple II and TRS-80 were introduced. IBM entered the market with the IBM PC, with a modular design that allowed for easy upgrades. Apple released the Macintosh with a graphical user interface, a major step towards the user-friendly computers we use today. The evolution didn't stop there. Computers continued to get smaller, faster, and more efficient. Today we have supercomputers, the fastest computers in the world, which use multiple CPUs grouped into compute nodes and can contain tens of thousands of nodes. They are used for complex calculations and artificial intelligence programs, pushing the boundaries of what computers can do. And that's how we arrived at the supercomputers of today, from a simple abacus. This journey, marked by human curiosity and innovation, has truly transformed our world. An operating system is the heart of a computer, but which one do you think is more popular? Let's dive into the world of operating systems and explore the three main players: Windows, macOS, and Linux. Each of these systems is unique, delivering their own set of advantages and disadvantages. First up is Microsoft Windows, the most widely used operating system globally. Windows is known for its broad compatibility and user-friendly interface. It's the go-to choice for gamers and business users alike, thanks to its extensive software support and flexibility. Next, we have macOS, the system powering Apple's range of computers. Now, macOS is a bit of an aesthetic marvel. It's sleek, stylish, and popular among creative professionals, particularly for tasks like video editing and music composition. However, it's worth noting that macOS is exclusive to Apple hardware, which can be a bit on the pricier side. Last but not least, we have Linux. This is an open-source operating system, meaning it's free to use and highly customizable. Linux might not have the same user-friendly reputation as its competitors, but it's a favorite among developers and those who like to tinker with their system. So which is the most popular? In terms of sheer numbers, Windows takes the crown. But popularity isn't everything. The best operating system for you depends on your specific needs and preferences. Maybe you value the creative capabilities of macOS, or perhaps you love the freedom and flexibility that Linux offers. But let's not forget about mobile operating systems. Apple's iOS and Google's Android have become ubiquitous in our everyday lives. They might have fewer features compared to desktop systems, but they're optimized for the functionality of mobile devices and can perform a variety of tasks. So each operating system has its own strengths and weaknesses and is suited for different types of users. No matter which one you prefer, it's clear that operating systems are critical in making computers accessible and useful to us all. Computers are no longer just tools, they're also intelligent machines. But when did this shift happen? You see, the journey towards intelligent machines began with the advent of supercomputing technology, which brought forth computers capable of performing complex calculations and solving problems that were once considered unattainable. These supercomputers, with their multiple CPUs and tens of thousands of nodes, have become the backbone of many artificial intelligence programs. But what exactly is artificial intelligence? Simply put, it's the field of computer science dedicated to creating machines that perform tasks requiring human intelligence. This includes learning, reasoning, problem-solving, perception, and language understanding. And as computers evolved, so did artificial intelligence. From the invention of the first electronic computer, the Atanasoff-Berry computer in the 1930s, to the development of the first programmable digital computer, the Mark I, in the 1940s, each advancement paved the way for the rise of artificial intelligence. Fast forward to the 21st century, and we're seeing AI integrated into our daily lives, from voice assistants like Siri and Alexa to self-driving cars. The impact of artificial intelligence on computers and our lives can't be overstated. It's not just about making our lives easier. AI is also opening up new frontiers in fields like healthcare, education, and business. It's enabling us to solve complex problems, make accurate predictions, and understand the world in ways we never thought possible. Artificial intelligence has transformed computers from mere tools to intelligent machines. And as we continue to innovate and push the boundaries of what's possible, who knows what the future holds? Did you know the first laptop was made in the 1980s? As technology evolved, computer hardware became smaller and faster, leading to the creation of the first portable computer, the laptop. The invention of the transistor in the 1950s dramatically improved the efficiency and size of computers, making them smaller and less power-hungry. This development was followed by the introduction of integrated circuits, or chips, in 1958, which further reduced the need for soldering and increased the speed of machines. The first laptop, the Osborne one, was introduced in 1981. It had a 5-inch screen, 2 floppy drives, and a handle for portability. It was a major breakthrough in the technology world, marking the beginning of a new era of portable computing. Since then, computers have continually shrunk in size while growing in power, paving the way for the sleek, high-performance laptops we know today. These advancements in hardware have not only made computers more powerful, but also more portable, allowing us to carry our work, our entertainment, and our connections with us wherever we go. The evolution of computer hardware has not only made computers more powerful, but also more portable. The world's fastest supercomputer is located in Japan. But what does it do? You might wonder. Well, supercomputers like Fugaku in Japan or Summit and Sierra from IBM are the epitome of speed and power in the computing world. They are not just one CPU, but rather tens of thousands of CPUs grouped together into compute nodes. This allows them to perform high-performance computing tasks, such as those needed for artificial intelligence programs. Supercomputing is measured in flops, or floating point operations per second. To give you an idea, a petaflop is a measure of processing speed that equals a quadrillion calculations per second. That's a 1 followed by 15 zeros. These supercomputers are connected by interconnects, allowing them to collaborate on solving problems and communicate with I/O systems. They're used for some of the most complex calculations and simulations in the world, from predicting weather patterns to understanding the origins of the universe. But where are we heading with all this power? The future of computing is looking towards quantum computing, a model that aims to solve problems beyond even the capabilities of today's supercomputers. Supercomputers represent the future of computing, solving problems beyond the capabilities of traditional computers. Computers are not just tools, they're also a crucial part of the economy. But how? Well, they've revolutionized numerous industries, enhancing productivity and efficiency in remarkable ways. From the healthcare industry, where computers aid in complex surgeries and record-keeping, to the business sector, where computers streamline financial transactions and online sales, their impact is profound and undeniable. The computer manufacturing industry itself contributes substantially to the economy. It creates job opportunities, fuels technological advancements, and stimulates economic growth. And let's not forget about the tech giants like Apple, Microsoft, and IBM. Their market value, measured in trillions of dollars, is a testament to the economic power of computers. The rise of artificial intelligence, powered by supercomputers, is paving the way for a new economic revolution. High-performance computing capabilities are solving complex problems, opening up new avenues for innovation and growth. In addition, computers have a significant role in education, fostering a skilled workforce for the future. They enhance teaching and learning, equipping people with the necessary skills for the digital age. Computers are an indispensable part of our economy, driving growth and innovation.